Given question is from pipelining. In the question they have given 3 instructions. We are having I1, I2, I3, and 3 instructions has been executed in 5 different segments: S1, S2, S3, S4, S5 stages of segments, and the segment delays for each and every instructions they have given separately. Now if the clock cycle time is 1.43 nanoseconds, then they have asked that what will be the total time to execute this particular loop. See, you can understand easily that this particular loop is having 3 instructions, I1, I2, I3 in sequence, and after that again we will have to execute the same. So for loop is also a branching statement, and if we will have to execute this particular loop 2 times, that means first I1, I2, I3 will be executed normally as according to our pipeline, but after I3 there will be a branching. That means this particular I1 again for the iteration number 2 will start when I3 will be completely executed. So if I can compute number of clock cycles for 1 iteration, then I can double number of clocks, and then I can get the number of clocks for 2 iterations. So I will make a timeline diagram for execution. So on the horizontal scale I have written all those number of clock cycles, and these are I1. Now I1 take 2 clock cycles for S1, so S1 and S1 will be executed in 2 clock cycles. After that 1 for S2, then after that 2 for S3, and after that 1 for S4 and 1 for S5. S4 and S5. Now I2 cannot start up to 2 clock cycle, just because up to 2 clock cycle I1 was executing in S1. So I2 will start from clock cycle number 3. It will take 1 clock cycle for S1, 1 for S2, and then 3 for S3. Now you just see its 3rd clock cycle, or S3 will start from 6, just because S3 segment is busy for executing I1 up to 5. So S3 will start from here and it will go up to 8. After that S4 will execute for 2 and S5 will execute for 2. That means S4 up to 10, and then S5 up to 12. Now for instruction number 3, S1 will start from clock number 4 and it will execute up to next 3 clock cycles. So S1 and S1. S2 can start from here only, S2 and S2. S3 can also start from here, S3. S4 will start from 11, just because up to 10 S4 is busy with instruction number I2, so S4 will start from 11, and after that S5 will be executing in or from 13, and it takes only 1 clock cycle for I3. So you can understand easily that for a single iteration it is taking 13 clock cycles. Then for 2 iterations, clock cycles will be equal to 13 multiplied by 2, that is 26. Now we will have to compute the time. So time will be equal to 26 clock cycles multiplied by 1 clock cycle time, that is 1.43 nanoseconds. So the answer will be 37.18 nanoseconds. So the range can be 37.1 to 37.2.